Tanmoy Biswas, I welcome you all in my channel Chemistry the Mystery of Molecules. So today I am going to explain a multiple choice question presented in front of you. So you have to say what is the product. 4 options are provided. 1 is the right answer. I shall be very happy if you pause the video and try by yourself and write your answer in the comment box. So obviously now I shall explain what is the answer. So let's start. Now, if you look at this molecule, this boron is actually a 6 electron species. Consequently, it prefers to fulfill its octet by taking 2 electron, and that's why it can behave as a Lewis acid. And in this case, this BC bond is stronger. Why this is stronger? So stronger, you can understand this phenomena by one canonical form. What do I mean? See, we know the fluorine, this halogens are orthopara orienting and deactivating, and they have lone pairs. So this fluorine and carbon belongs to same period element, is 2p second row element. So consequently, this fluorine can donate its electron. It can come here and it can come here. So what it will do, it will make this boron carbon bond from single bond to a partially double bond. Okay, so what is the benefit of this? We know the increase in bond order from single bond to double bond, the bond strength is increases. So if the bond strength is increases, then the bond is difficult to break, and that happens because of this para 1. You can say that's our ortho. Remember, in case of fluorine has 2 effect, one is minus I, another is plus R. In case of ortho, the minus I dominates, but in case of para, the minus I can't operate that much because this boron and fluorine are far apart. However, this plus R effect can dominate from the distance. Okay, so now second thing is this BH bond. If you look at the electronegativity value of boron is 2 and electronegativity of hydrogen is 2.1. Although the difference is significantly smaller, but still based on this we can say that this boron hydrogen bond is polar and this boron is delta positive and this hydrogen is delta negative. Okay, so what happens if you react this thing with alcohol whose hydrogen is delta positive? So this delta positive, this delta negative, they two react together and produce hydrogen. You can simplify this concept by calling up one reaction like sodium hydride plus water. So what it produces? They produces hydrogen gas. How? Because this sodium hydride is delta minus, or it's ionic hydride negatively, but in this case water, this hydrogen is delta positive, so they react and produce this hydrogen gas. The concept is this. Now how the reaction happens? If you look at very closely, as I told that boron is Lewis acid and this ethanol has oxygen has 2 lone pair of electrons. So what happened? These ethanol oxygen lone pair can coordinate to boron and make a tetra coordinated boron species. So this tetra coordinated boron species, what they can do, this, see, previously alcohols, this polarity, this versus this boron hydrogen polarity was not that much higher such that they can produce alcohol instantly, but after the coordination of this oxygen atom with boron, what happens? This oxygen having a formal positive charge, so consequently it becomes relatively more electronegative. And how it quench its formal positive charge? By removal of this proton, or in short we can say the polarity of these hydrogen increases further. So consequently the removal of these 2 hydrogen, what do I mean? This part in the form of hydrogen gas became easier. Okay, so after removal of hydrogen, what they produces? After removal of hydrogen, they produces this boron. Means this is also a tri-coordinated boron derivative, but there is a difference compared to the reactant versus this product. What is the difference? See, in this case boron is directly attached to oxygen which have 2 lone pair of electron, and these lone pair of electron could be donated to the boron such that this boron can neutralize or decrease its electron density to somewhat. And in this case this boron is also enjoying the octet and oxygen is also enjoying the octet, so it is not that much electron deficient, means this product is not that much electron deficient like the reactant one. Okay, so we understood that this is relatively stable. Now question that are these 2 CH5 in the same plane? No. Why? Because if they remain in same plane, they will face a severe steric repulsion. You may consider the concept of steric inhibition of resonance. The similar thing, because of this severe repulsion between these 2 fluoro group, what happens? This 2-phenyl group prefers to remain perpendicular to each other. What do I mean? One phenyl group obviously remain in plane with the boron and donates its electron density from this benzene ring to boron, and another remain out of plane. Okay, so in this way they can avoid the severe steric repulsion. Now second question is, why the reaction stop at this stage? Why not the another ethanol molecule attack the anionic species? What do I mean? That this is also a 6 electron species, you can understand. Why another ethanol molecule can attack and produce this thing? Okay, so now let's try to understand the phenomena. So what happens? See, this reactant is far more electron deficient or Lewis acidic, whereas because of this canonical form and attachment of oxygen, this boron is not that much electron deficient, as I told. So consequently ethanol can go and coordinate, but it is not, this coordination is not that much strong enough such that deprotonation will occur and boron will become a negatively charged species, means the formal negative charge will come on the boron. Point number 1. Second, if you look at this C5, C6, F5, these two groups are fairly big, and another case here one ethanol is attached. So after then addition of one ethanol molecule will also face severe severe steric repulsion. So that doesn't favor, but you can say that's that previously there was hydrogen. How this reaction happened? See, it was hydrogen, and in this case it is OET, and OET is far more bulkier compared to hydrogen. That's why reaction happened. Now we understood why this will not, and this is the answer. We understood. Now question, why not this BOET? Means this species can, and this in this case this C6F5 could be replaced by 2 molecules of ethanol to produce this. Just sometime before I have explained this carbon boron, this bond is multiple bond character, means more than double bond. So consequently what happens, this bond is significantly stable as well as stronger, and this ethanol molecule can't break it to produce this ethyl borate ester. So consequently reaction stop in this stage, means monosubstitution of the hydride by the OET group. So this is the overall discussion. So what you have learned today? We have learned today that it's a 6 electron species, this CB bond is significantly stronger, and this pentafluorophenyl bulkness, one ring remain perpendicular to another one. You can compare this concept with steric inhibition of resonance and mesitoic acid system. I have already discussed this thing previously, and the polarity of this BH versus OH is completely opposite. And the most important part, that is such kind of boron compounds can behave as a frustrated Lewis acid base pair. What do I mean? We know Lewis acid base pair means this Lewis acid plus this Lewis base. So Lewis base donates its lone pair to the Lewis acid and form a adduct. We know this thing very well, this adduct formation. But if this Lewis acid is very bulky, so if it is very bulky, so because of steric reason this coordination can't happen, and both this Lewis acid and Lewis base remain frustrated. Okay, the details discussion, for the details discussion you may visit one of my dedicated video. I have already explained in details. So this is the overall discussion, students. Thanks for watching. If you enjoy, then like, comment, share and subscribe my channel.